so we've been given, remember number 7 is the tricky one. So we've been given fx is gx over hx. So we've been told the actual values of g of 2 and h of 2. And we've been told the values of the derivatives when x is 2 for both g dash and h dash. So first of all, if we're trying to find the equation of normal, obviously to find the equation of any straight line we need to know the gradient and the point on the line. So let's go and try and find the gradient first. So we know that g dash will tell us the gradient for tangent, but we've got something divided by something else here, so this is a quotient. So let's remind ourselves of the quotient rule. Here we go. Okay, so this will be f dash. Oh, actually, this will be f dash 2 because we know the values. So we've got v. So in our case, so in our u, oh gosh, maybe we should rewrite it. We've got g and h. So we've got h times u, g dash, minus g times h dash over h squared. Hopefully that's easier. Right, so h, the value of that was 6. Let me see if I can color code this. So that's that one, so that's 6. And then we're timesing that by g dash, which is 5. And then we've got minus, and then g, which was 18, multiplied by h dash, which was 2, over, oh, you can't really see that. Okay, let's just stay black then. Over h squared, oh no, the red was h, over h squared. Okay, so that is 30 minus 36 over 36. So that's negative 6 over 36, which is negative 1/6. Okay, so that's the gradient of the tangent. So the gradient of the normal is going to be positive 6. And then we're going to stick that into the equation of a straight line. But, okay, so we know it's y equals 6x plus c. So to find the c, we need to know a point that it goes through. So they have told us, what's the best way to color code this one? Oh gosh, just make a color. Okay, so when x is 2, f of 2 is going to be g of 2 over h of 2. So that was 18 over 6, which is 3. So we know that this is going to go through the point 3, 2. So 3 equals 12 plus c, c equals negative 9. So that's the equation y equals 6x minus 9. Okay. Okay, on to part B. So remember, don't write on the paper for part B. Can't say it enough. Right, write down the median weight of rats. So we've got a cumulative frequency curve. So our frequency goes up to 80, so that means our median is going to be here at 40. So ideally we are drawing a straight line until we hit the graph, and then straight line down between 40 and 60, so that tells us it is 50. Find the percentage of rats that weigh 70 grams or less. Okay, so we need to find 70 on this axis. Let's choose different colour. So 70 grams. Oh gosh, that's way too big. So you're just going to have a ruler in the exam. So it's going to be a lot easier. And then I'm going to draw it across. Okay, so this is the value of 65. But the question was, write down the percentage of rats weigh 70 grams or less. Okay, so that is all of these people, or all of these rats. So it's 65 out of a possible 80 times 100. .25%. Remember, you can leave your exact answer or round it to 81.3. Alright, the same data was entered in the table. Write down the value of P. So from 0 to 30, that would be a value of 10. So P is 10. 60 to 90. Right, that's 30 to 60. Okay, so this was our first value. Then 30 to 60 was 45 because the 60 value was 55. And so we found the difference between those. 60 to 90. Oh gosh, let's draw a straight line. Oh gosh, this really isn't straight. Gives us 75. And from 55 to 75 is 20. And from 90 to 120 was that last 5. Okay, we're good to go. So that was 20. Use the values from the table to estimate the mean and standard deviation. Alright, so if it says from the table, we'd go back to our old-fashioned ways. So we'd find midpoints. So that's 15, 45, 75, and 105. We then multiply our values together and add them up and divide by total frequency. Or if you recall, we can stick these values into the calculator. Oh gosh. Okay, right. So stat clear list. I've got something in some of my lists, so I'll clear them. Alright, so when we're using stat edit in our first list, we're going to put our midpoints. That's 15, 45, 75, 105. And then we would put our values, so that's 10, 45, 20, and 5. That calc, it's just the one variable, so frequency list is this 2. So we have mean of 52.5. Remember that's the x bar, so the mean is 52.5, and standard deviation is this one here. Okay, so it's this one we're looking for, so it's 22.5. Find the percentage of rats that weigh 70 grams or less. Oh, it totally wrote that in the wrong place, sorry. This should be written up here. Assume the way these weights of these rats are normally distributed with the mean and standard deviation that we just found. Find the percentage of rats that weigh 70 grams or less. Okay, so we would draw a normal distribution. A mean of 52.5 and standard deviation of 22.5. So make sure you just follow through your values, even if you're not sure if they're right or not. So we want 70 grams or less. So we are going to do second. Here we go. We've got normal CDF. Left is small number, that's fine. Up at 70. Mean is 52.5. Standard deviation is 22.5. So 0.782. Oops. Okay. A sample of 5 rats chosen at random. Find the probability at most 3 rats contain 70 grams or less. Okay, so we can use our calc here. So this is a binomial distribution question. So we've got 5 rats being chosen, and we've got 0.782 is our probability of it happening, so that's the value, probability of R, and then we do 1 minus 0. I just write it because we can't be able to work it out. 1 minus 0.782 to the power of 5 minus R. Okay, but we can use our calcs for this. We want to know when at most 3 rats, so we want the probability that x is less than or equal to 3. So we want the cumulative. So we've got 5 trials. The value of P is 0.782. The X value we want is 3. That's 0.2999. So that's 3. Okay, this isn't the same answer as the mark scheme. Not 100% sure why that would be the case. Oh, they may have used the original percentage of 0.781650. Maybe that's why they've got that. But that's all correct working. Okay.